Hi, in this video we're going to look at a few examples of differential equations and determine if they are linear or nonlinear. Let's jump right into it. Our first example is 3x y double prime plus x cubed y prime minus cosine x times y, and let's say it's equal to the number 7. So first, let's notice that y and all of its derivatives are raised to the first power. So there's nothing like y squared or the square root of y prime, etc. So it's always y double prime, and it's really to the first power. Same thing here, same thing here. The second condition is that you have a pure function of x over here. So over here, there's no y's, so all is good. And the last condition is that in front of y and any of its derivatives, you only have pure functions of x. So 3x is okay, x cubed is okay, negative cosine x is okay. So the answer is this would be linear. Let's go ahead and do another one so that hopefully you can understand what is going on a little bit better. Let's say we have x squared y double prime plus y times y prime minus sine x times y equals e to the x. So in this case, this part's okay. There's no y's over here. Y and all of its derivatives are to the first power, so that's okay, and that's okay. Pure function of x. Oh, look at this. Game over. You cannot have a y in front of a y prime. Remember, in front of y and all of its derivatives, you have to have pure functions of x. So because of this, it's going to be nonlinear. Let's do more examples, because I think that the only way you can really learn this is by really just doing lots of examples. Let's say we have x, y triple prime plus, let's see, sine y times y equals 0. In this case, again, it's the sine y that really ruins everything, because we're not allowed to have a function of y in front of the y. If this was, say, a sine x, then everything would be linear, but in this case, it's a sine y, so it's nonlinear. Let's go ahead and do another one. How about something like this? Let's see, trying to think of ideas here. How about this? Y double prime plus y prime, and we have a square root, plus y equals x cubed. So in this case, the problem comes into play where I kept saying y and all of its derivatives have to be to the first power. Well, this is really to the 1/2 power, right? So this is going to ruin everything. So in this case, it's also nonlinear. Pretty interesting stuff. And again, it's through examples that you really get better. Let's do one more. So E, about cosine of x times y double prime plus e to the x squared times y prime plus sine x times y equals, x. So in this case, this one is linear, right? There's no issues here. Y and all of its derivatives are to the first power, so checks, checks, checks. And in front of y and all of its derivatives, you have, again, pure functions of x. So just a short video to give you 5 simple examples. Remember, it's going to be linear if y and all of its derivatives are to the first power. In front of y and all of its derivatives, you have pure functions of x. And on the right-hand side, you just want stuff with x's or a constant. You can't have anything with a y here. If you did have like a y here, by the way, what you could do is you could subtract it and bring it over. But if you have like y squared or something like that, it's going to fail. I hope this video has been helpful to someone out there. Good luck.